Alright everybody, today we're going to be looking at one-step equations with using the multiplicative inverse. It's a fun word to say. I recommend you practice it a lot because it's really fun. Multiplicative inverse. So what we've done so far is you guys have been able to solve one-step equations using the additive inverse, meaning you would add the opposite to both sides of the equation. The multiplicative inverse is a little bit different. Okay, when we're talking multiplication, we don't use the opposite sign, meaning if it's a negative multiplication, we don't use a positive multiplication. When we're talking about multiplicative inverse, we're talking about what is the opposite of multiplication. And of course, the opposite of multiplication is division. So for example, the idea of multiplicative inverse is this. If you had the number 3, okay, 3 is really a fraction, right? 3, if we really thought about it, is really 3 over 1. Okay? The idea of multiplicative inverse is you say, I'm going to take 3 over 1 and I'm going to multiply that by the inverse of 3 over 1, which is 1 over 3. Okay? So really, the multiplicative inverse is just multiplying by the reciprocal, and that should be a word that you guys should know from the last couple of years of elementary school. Okay, so 3 over 1, you would multiply it by 1 over 3. The multiplicative inverse, you use that to turn this entire problem into 3 over 3, which of course is equal to 1. So the idea of the multiplicative inverse is not necessarily to eliminate something, it's to turn something into 1. And the reason that we do that is what we're going to be talking about today. So here we go. When we were solving one-step problems with additive inverse, we discussed how the idea of that was to isolate the variable or get the variable by itself. Same thing with multiplicative inverse. However, the problem is written differently. When you have to use multiplicative inverse, the problem is usually written something like this, where you would have, let's say, 3y equals 12. Okay? Now what you need to remember about this, several things really, but the most important thing for now is to remember 3y. When you have 3y right here, what this really is this is saying 3 times y. Okay, it's a multiplication problem. There could be a multiplication point in between the 3 and the y. So that's the first thing we need to remember. So when we're using multiplicative inverse, what you also need to think about is if this is 3 times y, you can't just subtract 3. That doesn't work. Because if y was 5, then it would be 15 minus 3, and that would work. But if y was 2, then you'd have 6 minus 3, and that does not equal 12. So we don't know what y is. Okay? So we can't just subtract 3 like we did with the additive inverse. But what we can do is we can use the multiplicative inverse. And the way that works is this. Step 1 when you're solving a multiplicative inverse is always to start off by turning everything into a fraction. It'll just make the multiplication easier later on. And I know you guys hate fractions, but I promise you it's not going to be as bad as you think. Okay? So we're going to turn our numbers into fractions. Right? So the next step with using multiplicative inverse is we have to actually multiply by the inverse of the coefficient that we have. Okay, and this is the key part. You multiply by the coefficient. Okay, remember coefficient means the number that's right in front of the variable. It's multiplied to the variable. So the coefficient in this case is 3 over 1, which means if I want to eliminate 3 over 1, I have to multiply 3 over 1 by the inverse of 3 over 1, which is 1 over 3. And remember, just like when we're bench pressing, we need to do the same thing to both sides of the equation. So if I multiply one side of the equation by 1 over 3, I also have to multiply the other side by 1 over 3. Okay? So here we go. This is not as difficult as it looks. Please don't turn this off and freak out. Here we go. Multiplying fractions. Remember, when you multiply fractions, you just multiply straight across. So 1 times 3 is 3. 3 times 1 is also 3. We haven't done anything to the y yet, so we leave the y where it is. And then on the right side of the equation, we have 12 times 1, which is 12. and 1 times 3, which is 3. Okay? This is not that difficult, right? The numbers are really actually quite simple. So here's what we do next. Next step is just to simplify everything. If we look at this part here, 3 over 3, that's really what? And of course, we would hope that you would remember that 3 over 3 is really 1. Okay? So that is 1 times y equals 12 over 3. Remember that a fraction is really just a division problem. This we could read, instead of saying it's 12 thirds, or 12 over 3, we could say 12 divided by 3. And that's something that, again, you should hopefully know how to do. So 12 divided by 3 is 4. And at this point, you're going to say, well, Mr. Mitchell, that doesn't make any sense. The y isn't by itself. There's a 1 there. And yes, that is true. But you have to also remember this. If you multiply something by 1, it doesn't change. If you have 5 times 1, your answer is 5. So what we can do with that is we can look at this and say, well, yes, I have 1 times y, but when I multiply y times 1, what am I going to get? And the answer would be y, because 1 times y is just y. So I have y equals 4. And if I wanted to check and make sure my work is correct, which is a fabulous idea, you should all do that every single time you solve a problem, I would just take 3y equals 12. I'll rewrite it up here again just to make it a little clearer. And I'm going to substitute in my answer that I just got right down here. Okay, it says that y equals 4, so I'm going to put that in for y in my equation. So I'm going to rewrite it as 3, and remember this is multiplication, times 4 equals 12. And as long as 3 times 4 actually equals 12, then that means that I solved that problem correctly. And just so happens 3 times 4 does equal 12. So that problem was done correctly. Now, I'm sure some of you at this point are saying, Mr. Mitchell, why do I need to do that? I can just know that 3 times 4 is 12. And yes, you can, and most of you probably did that at the beginning and said 3 times y is 12. Well, obviously it has to be 4. The problem is, you don't always know what the answer is going to be, because sometimes you're going to get problems that look much more intimidating, maybe something like this. 3/5 m equals, let's say, 8/7. And now you have absolutely no idea what the answer is if you try to do this in your head. Okay? So, just to show you how multiplicative inverse can make your life so much simpler, let's just solve this real quick. Okay? Here we go. Remember that the idea of multiplicative inverse is to multiply both sides of the equation by the reciprocal of the coefficient. Okay? The inverse of 3/5 is 5/3, and we're going to multiply by that inverse. So both sides of our equation we're going to multiply by 5/3. On the left-hand side of the equation, and actually I'm just going to do a little squiggly line here to kind of separate what's going on so you don't get confused later. On the right-hand side of the equation, or left-hand side of the equation, 5 times 3 is 15, 3 times 5 is also 15, so we're going to have 15 over 15. On the right-hand side of the equation, we have 8 times 5, which is 40, and 7 times 3, which is 21. Now, what you have to remember, and I'm going to kind of skip a step here, so follow along, and if it's confusing to you, just look back at why I did this in the previous problem, and, you know, it actually does work. Remember in our previous problem, look over here really quickly, we had 3 over 3, right? Well, 3 over 3 eventually turned into a 1, which eventually got eliminated because there was no need for it. So on our equation that we just solved, 15 over 15 is also going to be a 1, which we will also eliminate because we don't need it. So I can just say that my answer is going to be, and I know I'm getting kind of tiny writing here, and I apologize for that, but I'm going to have an answer of m equals 40 over 21. And yes, we could simplify that, and yes, you probably should, but for the reasons that I just don't want to right now, I'm not going to. But this is why multiplicative inverse is so much simpler than trying to do this problem in your head. If you had to solve 3/5 m equals 8/7 and I said you had to do it in your head, I don't think there's a single one of you that could have solved it. But using multiplicative inverse, it's very, very simple. So there you go. That's how you use multiplicative inverse to solve a one-step equation. And we will look at using negatives in our next lesson. Thanks, guys. See you tomorrow.